All right, in this video, we are going to work the following problem. It says the position function f of t of an object in motion is given below, where t is greater than or equal to 0. Find the time intervals on which the object is speeding up and slowing down. Okay, so how are we going to do that? Well, first off, for speeding up, what's got to happen is that the velocity and the acceleration have the same sign. All right, so think of the velocity, right? Remember, we're basically traveling back and forth on a number line. So, and if the velocity is positive, then we're traveling in the positive x direction, let's say. And if the velocity is negative, we're traveling in the negative x direction, so to the left. All right, and just think of the acceleration as you're given a push, okay? So say you're traveling in the positive direction and somebody pushes you in that same direction, so they're basically like kind of pushing you from the back, you're going to speed up. All right, if your velocity is negative, so you're traveling towards the left on the number line, and your acceleration is also negative, that means you're getting a push in that same direction. So you're getting pushed in the direction that you're already traveling, you're going to speed up. Okay, and then for slowing down, it's the opposite. Okay, that should say speeding up. If you're slowing down, then the velocity and the acceleration have opposite signs. So again, imagine you're traveling to the right on the number line in the positive x direction, but then you're getting pushed in the opposite direction. Well, that's going to cause you to slow down. Same thing if you're traveling to the left. Okay, so that's the key to this problem, is to realize what we're looking for, right? When the problem asks, hey, when are they speeding up, we're looking for when the velocity and the acceleration have the same sign. When they're asking for slowing down, you're looking for where the velocity and the acceleration have the opposite sign. Also key here is to remember that t is greater than or equal to 0, right? T representing time in these problems, so we usually just start that at 0. We don't talk about negative values for time, generally speaking, okay? All right, so this is what we're after. All right, so to get there, what we need to do is to find the velocity function and the acceleration function and then make some sign diagrams for them, all right? So remember, the velocity function is the derivative of the position function. So the velocity function is going to be 3t squared minus 42t plus 99. Okay, and then the acceleration function is going to be the derivative of the velocity function, which will be 6t minus 42. Okay, and so we need some sign diagrams for those. I'm going to draw, let's see, the sign diagrams over here. So one for the velocity. Remember, t starts at 0, right? So my sign diagrams are going to look like this. And since we're talking about polynomials here, right, our f of t and all of these things are their domain usually is all real numbers, right? But for this problem, the domain of any polynomial, right, is usually all real numbers. But in this problem, they restrict the domain, right, down to 0, because that's just normally how these kind of models operate. All right. And so then after that, we are going to make a sign diagram for the velocity, the acceleration function. I usually like to line that up right underneath the one for the velocity, because we're going to have to look at both of them at the same time, like so. Okay, so let's start working on the sign diagram for the velocity function. I want to solve v of t greater than 0. All right, and so that will tell me where the velocity is positive, right? But actually, in the process of solving that, then I will actually get the answers to where it's negative as well. So that should be greater than 0. But in the very next step, right, since this is a quadratic inequality, then I'm going to set it equal to 0 and solve it out first. All right, so the first step in factoring would be to factor out a 3, right, since 3 goes into all of these. So that would be 14 plus 33. Oh, didn't mean for that to happen. Equals 0, and then I need to factor that out. So I need two numbers that multiply to give me 33, but add up to give me negative 14. So that is going to be negative 3 and negative 11. And this one is fairly easy, right? Because after I factored the 3 out, then I have a 1 here as the coefficient. So that means that once I find those two numbers, I can just put in there. All right. All right, so now this quadratic is completely factored. I have these three factors, 3, t minus 3, and t minus 11 equals 0. So when I multiply those three things together and I get 0, that tells me that at least one of these had to be 0. We know it can't be 3, right? Because, well, 3 is not equal to 0, right, in our class. So t minus 3 equals 0. And then t minus 11 equals 0. So I get t equals 3 and t equals 11. All right, so I need to take those and put those on the number line for the velocity function, right? So I put those on there. Again, make sure that you respect the order on the number line. The 11 has to go to the right of the 3. That's going to break the number line up into some number of pieces, right? 3 pieces. And so I need to pick test numbers on each piece and plug those in. All right. So I need to plug them into this inequality here. Okay. But it's just easier to plug them into this factored form right here. Again, when you're using this trick, if you've watched any of my previous videos, I warn you every single time, you got to be really careful when you do that, okay? You've got to make sure that algebraically this expression is exactly the same as that. Sometimes when you're solving an equation, you do stuff that would make it not equivalent. So just make sure that it's not. If you have a calculator, you can just plug it directly in here, but just a little easier to do it without a calculator by using this factored form. All right, so I'm going to plug these test points into this inequality. So first over here on this side of the 11, I'm going to pick a 12 right over here. So if I plug that in, I get 3 times 12 minus 3 times 12 minus 11. So that's a 1. That's a 9, right? And that's a 3, so I get 27 is greater than 0. All right, so I got a positive number here. That means that all of these numbers, right, on this piece over here, when I plug any number into the velocity function, I am going to get a positive number. All right. Next up, I am going to pick a 4 right in here and plug that in. So here I get negative 7 times 1 times 3 is negative 21. Okay, so that's a negative, so that means that the sign of any value, if I take any number in the interval between 3 and 11 and plug it into the velocity function, I will get a negative number. All right, and then same thing on the last number on this piece right here. Some people ask, hey, can I use the 0 there? And you can, as long as it doesn't make the, if it's on this very last piece, if you can use the 0 as long as it's not a solution of this equation right here. Okay, so in this case you can. If I plug the 0 into this inequality right here, I'm going to get 0 minus 0 plus 99. So I get 99 is greater than 0. So that will be a plus on that interval as well. Oops. So I put a plus there, meaning that if I take any number to the left of 3 and plug it into the velocity function, I'll get a positive number. All right. All right. So there's my sign diagram for the velocity. I need to also now make a sign diagram for the acceleration function. So I'm going to erase this stuff here. All right, and now basically we need to do the same thing that we did for the velocity function. We need to solve a of t greater than 0. Okay. So the inequality that we need to solve is 6t minus 42 is greater than 0. Okay. So we need to solve this inequality. This is actually a linear inequality, right? Which it almost, in the problems we've encountered in this class, it almost never, right, is one of these types of inequalities. So you can actually solve this the easier way, right? So I'll show you how to do that, but you got to be careful that you only use this method when this is a linear equation over here, or inequality, right? So we would just solve the way you learned in algebra class to solve these linear inequalities, like so, and then divide both sides by 6. Again, make sure that you are only doing this for something that looks like this, some number times t minus another number greater than 0. Okay, otherwise you're going to get an incorrect answer. All right, so I get t greater than 7. So you've got to put this on the number line as well. I like to line it up so that, right, 7 is somewhere between 3 and 11. So I like to make sure that these are lined up perfectly right here. It just makes it easier in the next step to compare those things. And since we did a of t is greater than 0, this tells you when it's greater than 0 for t greater than 7, right? So that would be over on this interval as well. So I would put a plus here, and because the graph of this function is a line, a straight line, right? Because it's a linear function, that means that this has to be a minus over here, okay? You can't make that jump to that conclusion with anything else other than a linear inequality like this, okay? Has to be this very specific type of problem, all right? If you're in my class, though, most of the acceleration ones will be linear, okay? But in general, you can't do that. So a lot of times people get tripped up on this because, they made it this far. They're used to solving the more difficult types of inequalities, the nonlinear types, and then they'll mess this up, right? And that happens all the time. You get used to doing the difficult problems, and then when you go back to the simpler problems, it throws you for a loop for whatever reason. So just be careful about that. You still can solve this the way that you solve those other equations. You could set it equal to 0 and solve. You get t equals 7, put that on your number line, and then plug in some test numbers. If I plug in 8, I'm going to get 48 minus 42, 6 greater than 0. So I get a plus. If I plug in the 0, I'm going to get minus 42 is greater than 0. So I'll have a minus right there. Okay. All right. So we have our number lines for the velocity and the acceleration. So you can read off your answer, straight from there. But what I like to do is to make a third number line. And then I like to, this is kind of difficult on the tablet that I'm on. So what I like to do is bring every number on each number line down to this third number line. So I'm going to bring the 3 straight down. I'm going to bring this 7 straight down. And I'm going to bring this 11 straight down. Wow, that was a really not a great. Line there. Okay, so I brought every number down. And then what I like to do is to bring the signs down, both signs. So on this interval from 0 to 3, I'm going to have a plus, and I usually write that on top, plus, and then a minus. And then between 3 and 7, right, you can look, I'll have 2 minuses. There's a minus on the one for velocity. There's a minus on the sign diagram for acceleration. So minus, minus. Then on this one, right here, we've got a minus for the velocity, and the acceleration would be positive, so it would be minus plus. Oops. And then on from 11 to the right of 11, right, I have 2 pluses. So I write them like that. 2 pluses on that one. Plus for the velocity, plus for the acceleration. All right, so that's what I get. And so now to me, then it's easy to read off my answer on this one. I'm going to write it over here to the left. So for speeding up, when is the object speeding up? Well, it's going to be speeding up when the velocity and acceleration have the same signs. So that's going to be right here between 3 and 7. And on this interval from 11 to infinity. I usually don't write the union sign on here. I usually just list them by commas. Your teacher might want you to put the union sign, but I actually think you probably shouldn't technically do that. All right, and next they want slowing down. So it's going to be slowing down on the intervals where the signs are different, right? So this one right here, from 0 to 3, and the 0, I usually write the bracket. That's the only one that I don't. I write the bracket where when I can, right? And that would be only if this was 0, like if this was a 0 of the velocity or acceleration or undefined in there. So, and then the other interval where the signs are different is here between 7 and 11. All right, and so now we have the intervals on which this would be speeding up and on the intervals on which it was slowing down. And that's it for this one.